Hi, I'm Adam, and I'd like to spend a couple of minutes today talking to you about the LHP Engine Control System, or LHP ECS. The LHP Engine Control System is based on National Instruments Compact Rio chassis and controllers and C-Series modules. The three key selling points of the LHP ECS are: one, it uses the NI direct injector driver technology to interface with either solenoid or piezoelectric direct fuel injectors. Two, it allows you to use the NI EPT engine position tracking software that accurately senses cam and crank position and reads the signals from those sensors. And three, it allows you on the ECS model to run LHP Panthera Rapid Controls prototyping suite that can allow you to run a Simulink model on NI hardware. So let's take a look inside the ECS and get into a little bit more detail about the capabilities of the system. So as we look inside this particular ECS, first of all, we notice that it has an NI 9068 controller. We have the flexibility to change out whichever compact Rio controller you need based on slot count, FPGA size, RT controller performance as needed. As we kind of move along here, the first module we have is a CAN module that allows us to talk to other CAN devices. The next one is what we call an AD combo device or module that allows us to read variable reluctance signals, Hall effect signals from cam and crank sensors. It also looks at analog inputs from either active pressure sensors like a intake manifold pressure sensor or a rail pressure sensor for a fuel system. It also can read thermistors like an engine coolant temperature sensor or an intake air temperature sensor. Then we have a couple of port fuel injector modules that allow us to drive port fuel injectors. They also have low side channels that allow us to actuate low side engine loads, things that you might think of would be something like an inlet metering valve on a high pressure fuel pump, or a high pressure valve on a high pressure common rail fuel system. Next we have a throttle module that features two H-bridge circuits inside of it to drive two bidirectional throttles. It also has a couple of analog channels that allow you to wire the throttle position inputs directly to that module. Next to that, there's a digital output module that can drive spark for a spark ignited engine or really any other low current digital output signal that you might need. And then on the end, there's a direct injector driver module that allows you to interface with direct injectors. Now, this particular ECS is set up in this fashion, but at LHP Technology Solutions, our number one goal is to help you solve your problem. So if you come to us with a particular design problem, we can customize this system however we need to make sure that it gives you the right I/O for the engine or any other system that you need to run and operate and get the best performance possible out of. One powerful feature of the LHP ECS is with all the space we have inside of it, we have plenty of opportunities to add additional I/O above and beyond what our standard offerings are. So if you need some particular measurement, for instance, you have to read an RTD temperature sensor, you have the ability to find an NI module, or we can help you select that module, and then add it into the system, and you can integrate that into the control code, and you'll be set up and running. So that's a little bit about the LHP ECS. Remember, the three key selling points of it are: one, the NI direct injector driver technology that lets you drive either solenoid or piezo direct injectors; two, the NI engine position tracking technology that allows you to sense cam and crank position with very high resolution; and three, the LHP Panthera RCP suite that allows you to run a Simulink model on an NI real-time controller. Thank you for spending a little bit of time today learning about the LHP ECS. If you have any questions, please feel free to send us an email through our website. Thanks for watching and have a good day.